Hello everyone. So in this video, I'll talk about the acronym I from the solid principle. Okay, so it stands for interface segregation principle. Straightforward. Okay. The definition also will go through it, and then after that, I'll go to the code. Okay, so that we can understand it much better. If I just read the definition, it states that no code should be forced to depend on method it does not use, or a client should never be forced to implement an interface that it doesn't use. In simpler terms, if I talk about, I should not be forced to implement any method which I don't need, okay, due to the issue of interfaces, accumulation or interfaces, many different methods put into a single interface, okay. So that can actually cause the classes which will implement those interfaces, they have to provide the functionality to that. If some of the functions are not required by my classes, I still have to give the functionality to them because I'm implementing that interface. This we should not do. To resolve this issue, we should segregate the interfaces depending upon the functions. Like some interfaces will only need some part of our functions, other interfaces need other part of our functions. So we should segregate them. This is what the basic idea is. Okay. We will go to the code to understand both the bad examples and the good examples. Firstly, yeah, I'll go to the bad example. I've created both bad and good example under this package. In the bad example, I created an animal interface over here. Interface is having two functions, fly and swim, like you can say feature of an animal. So I've taken up a two right now, a fly and swim. And then I've created two, you can say classes. Okay, one dog which is implementing animal. Okay, now the thing is like animal has two functions, fly and swim. So when dog will be implementing animal, he needs to override these two functions, that is fly and swim, but dog cannot fly. So the function is like not required by the dog, but still it has to provide implementation for it, which is not required. Okay, so this is the place where we are breaking the interface segregation. Okay, and we are violating the principle. And if I just go to the duck, duck can do fly and swim both because it's capable of. Okay, so that's why this is like a good part. But because of one class, I will be breaking this in the another class. That's dog doesn't need this function, duck might be needing it, but dog doesn't need it. Okay, but still have to provide the implementation of it. This is how we are breaking the code. Okay, if I just go to the complete code and explain to you running it out. Okay, so I've created an animal feature class, two functions over here, animal fly and animal swim, which will be taking a reference of animal and then calling the whichever functions are required, like fly and swim. So it's a straightforward. I've just created two functions for doing the you can say in between stuff. Okay, then I directly have a client. In the client, I'm creating an object of animal feature, and below you can see I'm also creating objects of dog and duck, but reference is of animal, that is my parent reference. Okay, because I will be passing them in my animal feature class. Okay, so animal feature is expecting an dog and animal reference. Okay, so animal fly, I'm passing the object of dog which is having a reference of animal. Similarly, I'm passing a duck. Okay, so if I just run this out, you will see I'm making animal fly, which is not a good thing. Yeah, see, dog cannot fly, but still it has to provide implementation for this function. Okay, so this is not a good way to write a code. We will try to see how we should be doing the segregation. Okay, if I just open the good example, now what I have done the good example is like now earlier we had this issue of fly and swim. Okay, now I've created two different interfaces. One is flyable animal, which is having a fly function, and then we have a swimmable animal, which is having a swim function. Okay, so now we have segregated the functions into two different interfaces. This is what my principle says. The interface segregation. Okay, so I'm following it. Now, if I just go to the dog, G stands for good example. Okay, so it will implement swimmable because dog can swim. Okay, and it will override the swim function. Okay, straightforward. Now, if I just go to the duck, you can see duck will be implementing both swimmable and flyable because duck can do both. And the moment it's implementing both the interfaces, it also has to provide override those functions. Fly is coming from flyable and swim is coming from swimmable. Okay, so duck can do both, so that's why it has overridden the both the functions and it's providing its own functionality. Here also I've created an in between class to call those functions, perform fly and perform swim, taking the different interfaces and calling their appropriate functions. If I just go to the client over here, again in client similar, like I've created animal feature object, and I've created objects of dog and duck. Okay, and I'm passing those objects. So this is how we are solving the issue of interface segregation. Okay, by dividing our interfaces into two different parts. Okay, one which is only required for one part of it, that's fly, or even if in future if you get some of the functions which are not required by the other classes, and also we should be doing this segregation. Okay, so I hope you would have understood it, but if still have some questions, you can put it in the comments. I'll go and I'll explain over there also. Yeah, that's all. See you in the next video. Bye bye.